Hi everybody, we got a test tomorrow. I wanted to go through a couple problems. So, remember to get a lot of sleep tonight, eat your breakfast in the morning, come nice and early, and it is a pretty tough test. I just looked over it, but if they follow the steps, they should do pretty well. Alright, so we'll just go over a couple review problems. This is just a practice test, so this is number 2. The first thing we always do is code the question. So each square represents one whole. So each is usually a very important word when we're talking about story problems, but this is not a story problem. So each just means this one, and this one. But if it was a story problem, we would underline it and put multiplication and division. But we can still underline it. Each square represents one whole. So this is one whole, one whole, one whole. What fraction does this model, so this is the question, and we're talking about fractions, does this model represent? So model is important too. So this whole thing is a model, and we got to find the fraction. The first thing we're going to do is I'm going to make a fraction with the unknown boxes. So we don't know what the numerator is, we don't know what the denominator is. Remember that denominator is all the parts in one whole. So we're going to take one of these and count all the parts. 1, 2, 3, 4. I'm not going to count these because remember the denominator is all the parts in one whole. And if I counted this one, I'd be going into 2 wholes. So there's 4 parts in one whole. And then the top one is going to be all the shaded parts. So I'm going to count all the shaded parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And put a 12 here. So the answer would be 12/4, which is D. And I'm just going to go through all of them. A is 1/12, and that would only be one shaded, so that can't be it. 3/12. Remember, is there 12? Is there 12 in one whole? No, there's only 4 in one whole, so that doesn't match our model. So it can't be this one. And 12/12. For the same reason, it can't be that one. Alright. Next one, number 3. Which equivalency statement is true? So, first we code our text. Equivalency means that one side is the same as the other side. Statement is true. So, is 2/3 equal to 2/6? No, that's not true, because even though they have the same amount of pieces shaded, the pieces are different sizes, because this size is going to have smaller pieces because there's more in the whole, and this size, this fraction is going to have larger pieces. And it's good to make a model. Let's make 2 about the same size because we want to compare the same size wholes, and we're going to chop this one up into thirds and shade 2 of them. 1, 2. So this one's 2/3, and now we got to make 6. So I'm going to first do thirds again, and then split every one of those in half. And now I have 6, and I'm going to do 2 shaded and 2/6. So this one's 2/6. So which one's larger? They're both 2 shaded, but these are bigger pieces. So this one's larger, which means these are not equal. So A is not equal, and that's what equivalency means. So this cannot be right because they're not equal. How about 4/6 and 4/3? Well, they both have the same amount of pieces again, but for the same reason, these are now different sizes. So this is going to be smaller pieces. 1, 2, 3, 4. It'd be shaded into here, and this would be 4 bigger pieces, 1, 2, 3, and then we would have to make another hole and do another piece. So this piece would be a lot bigger. So again, they're not equal. 1/3 and 2/6. I'm going to make 2 holes about the same size so I can compare them. I'm going to make the model 1/3. The bottom number tells me how many pieces, and then I'm going to make this one 6 pieces. And now I'm going to shade 1 of the pieces in the thirds and 2 of the pieces in the sixths. And now I have 1/3 and 2/6. So are those equal? Wow, those are so close. So what I should have done to really compare it is I'm going to make those 2/6 right under here. So I know I have the same exact size pieces. So there's thirds, but I'm going to cut it again to 6. And now I'm going to shade in 2. 1, 2. Now that I have them right on top of each other, I can say, hey, they are the same. So 1/3 is the same as 2/6. So I'm going to put an M for maybe on this one, and then go to the last one. Is 1/2 the same as 4/6? I'm going to try this one with a number line. This is 0, this is 1, and 1/2 would be in the middle. And for this one, I'm going to have to chop my number line into 6 pieces. Got to make my pieces even. So let me just check if that's 6 pieces. 1, 2, 3, 4, 5, 6. Okay. And now shade in 4. 1, 2, 3, 4. So actually that one's more than half. Half would be here. So this is a little bit more than half. So they're not equal. This goes right to here, right to halfway, and this one goes a little more than halfway. So these are not equal either. So answer is C. Alright, let's do one more. Let's do one of these. So it says find the total area of each shape. Show your work. So area is the inside of a shape, not the outside. The outside would be perimeter. If it said outside, or if it did say perimeter, we would add every side, 6 plus 2 plus 2 plus 2 plus 4 plus 4. But it didn't say perimeter, it said area. So we're going to have to find the inside. And the way we do that is rows times columns. So every time you see the area word, I want you to put R times C. But that only works for rectangles. And is this a rectangle? No, this is a weird shape. But we can make it into 2 rectangles by splitting it here, or we could have split it straight down. But I'm going to split it here, and now I have 2 quadrilaterals that I can do my rows times columns. So here I'm going to put R times C, and here I'm going to put R times C. Now what is the rows? Rows go this way, so I have 2 rows, so 2 times, and then columns go down, and I also have 2 columns, so 2 times 2 for the top, which makes 4. So my area for the top square or rectangle is 4, no, it is a square because it's the same length sides, so it's 4 square feet. Now I got to do the same for the bottom. You might think the rows are 6 because it has a 6 here, but remember the 6 is for this whole side, and we cut this side, so it can't be 6 anymore. So I'm going to look over here. It's 4. So the rows are 4, and then I am going to put columns. You might think, oh, columns is 2 because the 2 is up here. But remember that 2 is only from here to here. So I'm going to look down here. Oh, there's my whole length, or columns. So it's 4 times 4, which is another square. 4 times 4 is 16. And now I have the area for this square and the area for this square. And I have to add them up. 16 plus 4 equals 20. 20 square feet.